Good morning, children. Today we will be discussing about biomolecules. In biomolecules, one of the biomolecule is your carbohydrates, which is a good source of energy and primarily produced by plants. Earlier definition of carbohydrates was hydrates of carbon. Hydrates of carbon. Few carbohydrates fit into this, and few compounds are there which are carbohydrates does not fit to this formula, general formula, and few compounds are there which fit into this general formula. CXH2OY is not a carbohydrate. For example, you see glucose formula is C6H12O6, can be written as C6H2O whole 6. That is, it fits into this general formula, hydrates of carbon. It is a glucose is a carbohydrate. Then the other one is your acetic acid. Acetic acid. Formula is CH3COOH. Can be written as C2H2O. How many are there? 3 plus 1, 4. Put it here 4. I think this fits into this general formula CXH2OY, but this is not a carbohydrate. Another one is a carbohydrate named as rhamnose. Its general formula is C6H12 C6H12O5. It is a carbohydrate but does not fit into the general formula of CXH2O whole Y. So this definition as carbohydrates as a hydrate of carbon was given up. Now the new definition comes here. The new definition is the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones or the compounds which produce such units on hydrolysis. I repeat, the carbohydrates may be defined as optically active polyhydroxyaldehydes or ketones or the compounds which give such units upon hydrolysis. Now, classification of carbohydrates. Classification of carbohydrates. Carbohydrates. One is monosaccharide, oligosaccharide, and last one, polysaccharides. In our syllabus, we are having monosaccharides only, oligosaccharides and polysaccharides we don't have in our syllabus. So monosaccharides can be defined a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehydes or ketones. These are the simple carbohydrates which upon hydrolysis do not give polyhydroxyaldehydes or ketones. Examples: glucose, fructose are there. And oligosaccharides means those carbohydrates which upon hydrolysis give 2 to 10 monosaccharides upon hydrolysis, and polysaccharides means which gives more than 10 monosaccharide units upon hydrolysis. Now let's go for monosaccharides, since these two are not there in our syllabus. I hope it is clear. Under the heading monosaccharides, we will go for glucose. We'll go for glucose. Its preparation. Number 1. From sucrose. That is your cane sugar. Sucrose, on boiling with dilute hydrochloric acid or sulfuric acid, we get equal amount of glucose and fructose. C12, H22, O11 plus H2O, acidic medium, we get C6, H12, O6 plus C6, H12, O6. Glucose, equal amount of glucose and fructose. From cane sugar we get glucose like this. Another one is your from starch. C6, H10, O5, whole N. This starch glucose is obtained from starch commercially by hydrolysis of starch by boiling it with dilute H2SO4. By dilute H2SO4. At 393 Kelvin and 2 to 3 atmospheric pressure, we get glucose only. Glucose. N C6 H12 O6, here will be N. Glucose. So this is your commercial preparation of glucose from starch and From sucrose, it can be prepared in lab. Upon acidic hydrolysis, we get equal amounts of glucose and fructose. Now coming to structure of glucose. Structure of glucose, number 1. Its formula is C6H12O6. Number 2. On prolonged heating with hydrogen iodide, we get normal hexane. This proves that all these 6 carbon atoms in glucose are arranged in a single chain. We can write CHO, CHOH whole 4, CH2OH. With HI, the heat, we get CH3, CH2, 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 CH3. This is a glucose. On prolonged heating with hydrogen iodide, we get normal hexane. This proves that all the 6 carbon atoms in glucose are arranged in a single chain. Next is glucose on reaction with hydroxylamine gives oxime, and glucose on reaction with hydrogen cyanide gives cyanohydride. This proves the presence of a carbonyl group in the compound. So glucose on reaction with hydroxylamine NH2OH, we get oxime. Already we have discussed in the chemical properties of aldehydes and ketones. And glucose on reaction with HCN form cyanohydride. This proves that glucose contain a carbonyl group. This carbonyl group can be an aldehyde or a ketone. So, fourth point is, we have to rub from the top. Fourth point is, when glucose is reacted with bromine water, we get a carboxylic acid, gluconic acid. So this proves that carbonyl group present in glucose is an aldehyde. So it is your CHO, CHOH, whole 4, CH2OH. On reaction with mild oxidizing agent, that is bromine water, we get gluconic acid, COOH, CHOH, whole 4, CH2OH. So in this particular case, glucose reaction with ammonium hydroxylamine to get oxime, its reaction with hydrogen cyanide to form cyanohydrine proves that there is a carbonyl group in glucose. It can be an aldehyde, it can be a ketone. This particular reaction, glucose on reaction with mild oxidizing agent gets oxidized to gluconic acid. This proves that the ketonic group, the carbonyl group present in glucose is an aldehyde and not a ketone. Acetylation of glucose with acetic anhydride gives pentaacetate, which confirms the presence of 5-OH group in glucose. Next point is on oxidation with nitric acid, glucose as well as gluconic acid both yield a dicarboxylic acid that is called the saccharic acid. This indicates the presence of a primary alcoholic group. At last we will be discussing about the structure. Primary alcoholic group, that is one OH group is of 1 degree, that is primary. Next is we can go for, based on that, we can go for the structure like this. One, 2, 3, 4, 5, 6. You draw like this. It is your double bond, oxygen, single bond, hydrogen. First, second, third. OH group will be here and H group will be this side. And rest it will be your OH, 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 and here is your H, 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 and then H. This is the primary alcohol. Whereas the other 1, 2, 3, 4, they are the secondary alcohol. I hope today's class is clear to you. Thank you.